4.2 Inverse of relations and functions. So recall the following inverse operations. Let's say I start with an x. If I add 2 to it, if I want to undo that operation, the inverse operation would be to subtract 2. Right, so if I add 2, if I subtract 2 to it, right, notice that I end up with what I started with, x. If I have an x and I take the square root of that, if I want to undo that, right, I can take the square, right? To undo the square, we take the square, and they undo each other, or they cancel each other out, giving you an x. So notice we have operations that are inverses. How about functions? What if you have a function? So the inverse of a function f of x is written as f inverse of x. Okay, so it's f of x, but with a little -1 symbol as a superscript. And the way it's read is an f inverse of x. Okay, be careful here, that is not an exponent. So normally if you have like x to the -1, you flip it, so it's 1 over x, right? 1 over x to the positive 1, giving you 1 over x. Right here, that -1 is not an exponent. It's not a power. It's strictly notation. Okay, so it's strictly notation telling you that this is the inverse function. Let me talk to you about functions for a moment. If I have f of x equals 2x plus 1, this means whatever you plug in, right, whatever you plug in, your input, multiply by 2 and then add 1. So if I have that function notation, let's say I put in 3, that means if I plug in, right, on the inside, if my input is 3, I'm going to multiply by 2 and add 1. That's the rule. So 2 times 3 is 6. 6 plus 1 gives me 7. Do you see this notation, right? The function notation tells you what you have for your input and tells you what you'll get out for your output. We could rewrite this whole thing as y equals 2x plus 1, right? And it would give me the same thing. When you see this f of x notation though, like f of x, g of x, h of x, that type of a thing, one way you can think of it is you're naming the equation, like f, g, and h, instead of all of them being y equals. But it also means what you have is something called a function. So if you remember from algebra, a function is where for every input, there is exactly one output. One output. Okay, so it's a specific type of relationship. So if I have f of x, if I want to undo that whole thing, what you can do is take the f inverse of that whole thing, and they undo each other, giving you the x that you started with. Okay, so again, let's say you have an x, and you do a bunch of operations to it. So the rule is you take g of x, like multiply by 2, add 1 type of a thing. If you wanted to undo the entire function, if you want to take the inverse function, you would do g inverse of the entire thing, and these would cancel each other. They would undo each other, leaving you with just x. For 4.2, this is what you need to be able to do by the end of the lesson. Given a table, graph, or a function, you have to be able to find the inverse. We're focusing mostly on finding the inverse of a function, but you still need to be able to find the inverse if you're given a table, like a set of points, x, y points, or if you're given a sketch of a graph. Let's start with finding inverses of a function. So I'm going to show you 2 methods. The first method is a intuitive method. We're going to call that the shoe on, shoe off method. And then the second method will be an algebraic method. So let's think about it. You are leaving your house. So you put your socks on, then you put your shoes on, and then you tie the laces. Okay, you go outside and you come back home. What do? You untie your shoelaces, you take your shoes off, and then you take your socks off. Notice we had to undo our actions, but in reverse order. So when you use a shoe-on, shoe-off method to find the inverse functions, you perform inverse operations in reverse order. Right? You had to, if you put your socks on, you have to take them off, but it's going to be in reverse order. Here's an example. Find the inverse. F of x equals 5x cubed minus 4. You stand at the x and you ask yourself, what's being done to it first? You cubed it. Then you multiplied it by 5. And then you subtracted 4. So how do we undo that? We have to go in reverse order. We add 4. What's the inverse of multiplying by 5? Divide by 5. And then what's the inverse operation for taking the cube? It's taking the cube root. So that's the inverse operations in reverse order. So what we do is we are going to have f inverse of x because we're taking the entire function and finding the inverse. You start with the x and you're going to add 4 to it. Then you take the entire quantity and divide by 5. And then you take that entire quantity and take the cube root. And that is your final answer. When it comes to finding inverse functions, you do not need to worry about simplifying your expression. So don't worry about rationalizing the denominator, multiplying things out, etc. Let's take a look at another example. Find the inverse. So we take a look at what's happening here. To the x here, you first take the power of 5. So you raise it to the exponent 5. So you raise it to the 5th power. Then you divide it by 2. And then you added 1. So let's go in reverse order, undoing this. So how do I undo adding 1? Subtract 1. Undoing divided by 2, the inverse would be multiplying by 2. And how do you undo raising something to the power of 5? You take the 5th root. Okay, so for our final answer, you would say the inverse function, so g inverse of x. Notice right here that the inverse, the -1 notation comes after the g but before the parentheses, is equal to, you start with the x. What do we do first? You subtract 1. Then you multiply 2 to the entire quantity. And then you take the 5th root of that entire quantity. Okay? So g inverse of x is 5th root of the quantity 2 times x minus 1. If you wanted to distribute that too, and get g inverse of x is equal to 5th root of 2x minus 2, that's also okay, but you don't have to do that. Remember, when you're finding inverse functions, you do not need to simplify your answer. Go ahead and try this problem. The correct answer is C. So let's take a look at a second method of finding the inverse of a function. So what you do here for this algebraic method is you swap x and y and solve for the new y. So here's the same example. Find the inverse of f of x equals 5x cubed minus 4. So if I rewrite that, if I rewrite f of x in terms of just y, I get y equals 5x cubed minus 4. Now we have to swap the x and y because when you have an inverse, you're swapping things. So you get x's wherever you see y, and you put a y wherever you see x. So we just swap their locations. And then you solve for your new y. So I add 4 to the other side, divide by 5, and to get the y by itself, we take the cube root of each side. So we get y equals cube root of x plus 4 over 5, but we rewrite that using inverse notation. So since I had f of x, my final answer is going to be f inverse of x equals cube root of x plus 4 over 5. Go ahead and try this problem here. The correct answer is A. How about finding an inverse from a table or a graph? Let's say I give you a table 2, 0, 3, 1. So if I were to sketch that, I would get 2, 0 and 3, 1. And if I asked you, let's call this like f of x. If I asked you to find f inverse of x in terms of the table, what would you have to do? you just swap the x and y. So instead of 2 comma 0, you're going to have 0 comma 2. Instead of 3 comma 1, you're going to have 1 comma 3. 1 comma 3. So this table of points, the set of points represent the inverse of f of x here. And notice when you see the graph, they are symmetrical over the diagonal. So if I have a diagonal line at y equals x, so 0, 0, up 1 over 1, if I were to graph that, an invisible line here, notice that your points are symmetrical along the line y equals x. So when you find an inverse from a table, you swap the x and y points. When you're finding the sketch of the graph, you still have to swap the x and y points, but essentially what you'll see is that you have a reflection across y equals x. So to graph inverses, reflect points across the line y equals x. Okay, so again, when you have a table or when you're plotting the points, it's the same as switch the x and y values in each pair, right? Because remember, in inverse functions, you swap the x and y. Try this problem here. Which graph is the inverse of the graph of f of x? The correct answer is B, because it is symmetrical along the diagonal y equals x. Let's take a look at this last example here. If you have f of x equals 2 to the x, we have an exponential growth or an exponential function here. Let's see if we can sketch this. Let's go ahead and make a table. If I plug in like 0, I get out 1. If I plug in 1, I get out 2. If I plug in 2, 2 squared is 4. If I plug in -1, I get 1/2. If I plug in -2, I get 2 to the -2, which is 1 over 2 squared, which is 1/4. So let's go ahead and graph that. So 1, 2, 1, 2, 1, 2, 3, 4. Okay, so if we graph this exponential function here, -2 comma 1/4, -1 comma half, 0 comma 1, 1 comma 2, 2 comma 4. We are going to have an exponential growth function that looks something like this. Okay, and remember our horizontal asymptote is here. What if I were to ask you to find f inverse of x? Okay, so we'll fill out this function in a little bit, but let's go ahead and make a table and also sketch it. So remember, if I were to make a table of values, we would have to flip all the values. So I would get all the x, y's are going to get swapped. So it would be 1/4, -2. 1/2 comma -1, 1, 0, 2 comma 1, and 4 comma 2. Let's go ahead and plot this. 1/4 comma -2, 1/2 -1, 1, 0, 2 comma 1, and 4 comma 2. Okay. So here I get this sketch. And notice that here you're going to end up with a vertical asymptote, right? Because things are flipped over the diagonal, so it makes sense. Again, remember, when you have inverses, they are going to be symmetrical over the diagonal. So like 0, 0, 1, 1, 2, 2. Notice that it's symmetrical over the diagonal line y equals x. Okay, so there's my table of points if I wanted to find the inverse. There's my sketch, diagonal, symmetrical over the diagonal. But how would I write this inverse function as a function, right? So I have 2 to the x. What is the inverse of 2 to the x? That is log base 2 of x. So the inverse of an exponential function is a logarithmic function. And we'll learn more about this next class.